In the previous video, we derived the formula for the shortest distance between skew lines. In this one, we'll practice applying it. Here's the first problem. Find the shortest distance between these two lines. Pause the video, give this a try. Okay, so these are the two lines. We have this first line r equals to a1 vector plus lambda b1 vector. Here this line passes through this vector a1 and is parallel to this vector b1. And we can figure these two vectors out by looking at it. A1 vector is I cap plus j cap and b1 vector is 2i cap minus j cap plus k cap. Similarly, we have a2 vector plus lambda b2 vector. We can get a2 and b2 from this equation. So let's write them down. A1 vector is I cap plus j cap. A2 vector is 2i cap plus j cap minus k cap. And then we can also write b1 and b2 vectors. b1 vector is 2i cap minus j cap plus k cap. And b2 vector is 3i cap minus 5j cap plus 2k cap. Alright, so we have these four vectors. Our first job is to find the difference between a1 and a2. So let's find a2 minus a1. That's going to be equal to I cap. This cancels out. Minus k cap. So a2 vector minus a1 vector is I cap minus k cap. Now let's find b1 cross b2 vector. So let's take the cross product of these two. So we'll get ijk, determinant of ijk, 2 minus 1, 1, 3 minus 5 and 2. So let's simplify this. We have I cap times minus 2 plus 5 minus j cap times 4 minus 3 plus k cap times minus 10 plus 3. So this becomes 3i cap minus j cap minus 7k cap. So this is our b1 cross b2. Let's also take the magnitude. So mod of b1 cross b2, that's going to be square root of 9 plus 1 plus 49. That's 10 plus 49, that's 59. So that's square root of 59. All right. So now we have the raw materials ready. Let's find the distance between these two lines. The shortest distance between these two lines, that's d, that's equal to mod of numerator has b1 cross b2 dot a2 minus a1 and the denominator has mod of b1 cross b2. So root 59 goes here and the dot product of b1 cross b2 and a2 minus a1 comes in the numerator. So let's find the dot product. That's going to be equal to 3 times 1 minus plus 7 times 1. So that's 3 plus 7 divided by root 59, mod of it. So that's 10 by root 59. That's the distance between these two skew lines. Let's try one more. Find the shortest distance between these two lines. Pause the video, give this a try. Okay, let's do this together. Again, same approach. R equals to a1 vector plus lambda b1 vector. We'll get a1 and b1 from this equation and we'll get a2 and b2 from this equation. So a1 vector is I cap plus 2j cap plus k cap. A2 vector is 2i cap minus j cap minus k cap. B1 vector is I cap minus j cap plus k cap. And b2 vector is 2i cap plus j cap plus 2k cap. Alright, let's find the difference between a1 and a2. So a2 minus a1, that's equal to minus I cap plus 3j cap plus 2k cap. Now let's find the cross product. b1 cross b2, that's equal to the determinant of ijk, 1 minus 1, 1, 2, 1, 2. So let's simplify this. This is I cap times minus 2 minus 1 minus j cap times 2 minus 2 plus k cap times 1 plus 2. So this becomes minus 3i cap, this cancels out, plus 3k cap. Let's take the magnitude. Mod of b1 cross b2, that's equal to square root of 3 square plus 3 square, that's root 18, that's 3 root 2. Alright, now we're ready to plug in the values. The distance between these two lines, the shortest distance, that's equal to mod of b1 cross b2 dot a2 minus a1. So the dot product of this and this divided by mod of b1 cross b2, which means divided by 3 root 2. So let's take the dot product. We have minus 3 times minus 3, that's 3. And then we have 3 times 2, that's 6. So 3 plus 6 divided by 3 root 2, mod of it, that's 9 by 3 root 2. That's going to be 3 divided by root 2, or if we simplify it, that's 3 root 2 by 2. So this is the distance between these two lines. Now in these two problems, we were given equations in the vector form. Now let's see how to deal with Cartesian form. Find the shortest distance between these two lines. Pause the video, try this out. All right, let's do this together. Now, there's also a formula for Cartesian form. We've derived it, but I recommend that you convert this into vector form and then use the same vector form formula. So let's do that. R vector equals to A1 vector plus lambda B1 vector, and R vector equals to A2 vector plus lambda B2 vector. Let's find A1, B1, A2, B2 from this Cartesian form. Let's quickly convert. A1 vector will come from the numerator. So in the numerator, we have x minus x1, y minus y1, and z minus z1. This means the point that the line passes through is minus 1, minus 1, minus 1. This makes A1 vector as minus I cap, minus j cap, minus k cap. Similarly, A2 vector is 3, 5, 7. This line passes through 3, 5, 7. So A2 vector is 3 I cap plus 5 j cap plus 7 k cap. We can get B1 and B2 from the denominators. So B1 vector is 7 I cap minus 6 j cap plus k cap, and B2 vector is I cap minus 2 j cap plus k cap. So now that we have A1, A2, B1 and B2, we can start working with these values to get the shortest distance. Let's find the difference. A2 vector minus A1 vector, that's equal to 4 I cap plus 6 j cap plus 8 k cap. Now let's take the cross product. B1 cross B2, that's going to be I j k. 7 minus 6, 1, 1 minus 2, 1, determinant of this. So that's I cap times minus 6 plus 2 minus j cap times 7 minus 1 plus k cap times minus 14 plus 6. So this becomes minus 4 I cap minus 6 j cap minus 8 k cap. So that's B1 cross B2. Let's take the determinant. That's going to be square root of 4 square plus 6 square plus 8 square. So this is square root of 116. That's 4 times 29. So this becomes 2 root 29. That's B1 cross B2. Now let's find the shortest distance. That's going to be mod of B1 cross B2 dot A2 minus A1 divided by B1 cross B2 mod. So 2 root 29 in the denominator and the dot product of this and this in the numerator. So the dot product is minus 4 times 4 minus 16, 6 times minus 6, that's minus 36, and 8 times minus 8, that's minus 64. So minus 16 minus 36 minus 64 divided by 2 root 29 mod of this. So that's, if you add them up, this is 16, 36, 64. So that's 116 in the numerator and 2 root 29 in the denominator. So this cancels out. This makes 2 root 29 because 116 is the square of 2 root 29. So the answer is 2 root 29. Let's solve one more problem. Find the shortest distance between these two lines. Pause the video, give this a try. Okay. Now if you take a closer look, these lines need some cleanup. They're not directly written in the form of A1 vector plus t b1 vector or A2 vector plus s b2 vector. These variables t and s, they're not separated. They're working with i's, j's and k's. So what we need to do is separate all the t's and separate all the s. So let's do that. If we clean them up, we have I cap minus 2 j cap plus 3 k cap. That will be our A1 vector. And then we have t, if we take t common, we have minus I cap plus j cap minus 2 k cap. So this will be our B1 vector. Similarly, here we have I cap minus j cap minus k cap. That will be our A2 vector plus s common I cap plus 2 j cap minus 2 k cap. That will be our B2 vector. So now we have A1, A2, B1 and B2. Let's write them down. A1 vector is I cap minus 2 j cap plus 3 k cap. A2 vector is I cap minus j cap minus k cap. B1 vector is minus I cap plus j cap minus 2 k cap. And B2 vector is I cap plus 2 j cap minus 2 k cap. Now let's start working. A2 minus A1, that's I cancels out. That's minus plus 2, that's plus j cap minus 4 k cap. That's A2 minus A1. Now let's find the cross product. B1 cross B2, that's determinant of I, j, k, minus 1, plus 1, minus 2, plus 1, plus 2, minus 2. All right. So this becomes I cap times minus 2 plus 4 minus j cap times 2 plus 2 plus k cap times minus 2 minus 1. So this becomes 2 I cap minus 4 j cap minus 3 k cap. That's our cross product. Let's find its magnitude. b1 cross b2, that's equal to square root of 4 plus 16 plus 9. That's 29. So that's root of 29. All right. Now let's find the shortest distance. That's mod of b1 cross b2, that's this, dot a2 minus a1, that's this, divided by mod of b1 cross b2, that's this. So the dot product becomes 2 times 0 minus 4 times 1 minus 3 times minus 4. So that's minus 4 plus 12 in the numerator and root 29 in the denominator, mod of this. So that's 8 by root 29, or if we rationalize this, that's 8 root 29 by 29. So this is how we calculate the shortest distance between two given skew lines.